Today would like to just look at something very small. This one could have just this maybe funny type of truss that goes like this, and then from there but unfortunately the architect has opted for something like this one above. So the thing that we can do, we have two options here. We can protrude, make sure that both of these red columns protrude, right? And then we can add in maybe a tie back here and a tie back there, thus reducing the cantilever here. So these ones are said to be RC, those ones, both of these columns. An alternative solution to that, we can also make use of this support and then use we use steel poles to support. But now that means this has to be stable, because we have something like this, and then forces from there, they are majority of the time, well, yeah, it now depends on the span. It could not be stable. That's why we actually have to do analysis, so that we can find out whether this extra arrangement is stable. Then maybe as compared to this, we can just use cables here, which are just cables. Alright, with this type of truss now, that the specified truss, we'll start having problems here when it comes, say, to the fabrication part. That's when we have to go with something like a hollow circular section, sorry, or maybe but a hollow tube. Now this one is difficult when joining, when it comes to joining them in this kind of parabola, but it can all be done. That's the thing, we can all do it. Okay, so this is what the preliminary, right? We also have to know the span to D ratio, span over D ratio, but well, for a normal truss we have them 12 to 15, but this part is greatly cantilevered, and we also have to put this into consideration. The effect of the cantilever can actually affect everything, let me say. And then as well as the type of truss, this goes in favor of a parallel chord type truss, so that's what we have to design for. And now let's write, this is just the same thing here. So if we're actually going to go with this type of truss, we also have to bear in mind that all these forces from the truss are just going to end up here, and as designers we have to know that we should have a gutter here, so something that looks like this for water there, else we make sure that this roof slopes downwards. So all this has to be like that. That's the roof now. Okay, interesting. So we have a span of 8 meters, and then over here, so all of this, yeah, the most important part, the span, we are spanning 8 by 8 right here. So So let's try to come up with a model in Start Pro on how to do it, but using the specified truss that the architects gave us. So yeah, that means use of this truss will change everything. That's what we should know. Use of this truss will even change the outlook of the stadium. As you can see, it looks like this, but now with the curved kind of truss, it's just going to look something like this instead of. So yeah, that's what the proposals came in to be. So as a designer, all I just do is size the members, and then we give it to the detailer, like